Good day, everyone. Welcome to another math series. I am Dominic Grigor Bimanuel, your instructor for today. So, our topic for today is all about the other improper integral of type 2. So, we all know that we tackle improper integral type 1 before. So, now let's proceed to improper integral of type 2. So here are the definitions that we need to know. In letter A, if f is continuous on A and is discontinuous at B, then our formula is equals to integral of b of a f of x dx equals to limit where t approaches to b from the left, integral of t and a f of x dx. So if this limit exists, this will be a finite number. And B, if f is continuous on A and discontinuous at continuous at B and is discontinuous at A, then our formula or our case is integral of b of a f of x dx limit where t approaches to A from the right, integral of b and t f of x dx. If this limit also exists, it will become a finite number. So the improper integral of b and a f of x dx is called convergent if the corresponding limit exists, and divergent if the limit does not exist. So if it is existing, it will be convergent. If it is not, it is divergent. So let's proceed to letter C. If f has discontinuity at C, where a is less than c and c is less than b, and both integral of c and a f of x dx and integral of b and c f of x dx are convergent, then we define integral b of a f of x dx is equals to integral of c of a f of x dx plus integral of b and c f of x dx. So these are the cases that we need to memorize or to know for us to solve a different type of problem in this improper integral. So let's proceed. So now let's proceed to the first problem. So we have problem here with integral with an upper boundary of 2, a lower boundary of 0 dx over x minus quantity of x minus 1 squared. So this case is suit for the case number 3 and type 2, because this f has discontinuity at C, where A is less than C and C is less than B. So therefore we need to apply this. So for this, we need to let C and any real number. So I pick 0. So now let's proceed to apply it. So it will become equals to the limit where t approaches to 0 from the left, t 0 f of x dx plus s. I used t and s as the approach limit where s approaches to 0 from the right, to s f of x dx. So now we will substitute the f of x dx to the equation. This will become limit where t approaches from the left, integral of t 0 dx over x minus 1 squared plus limit where s approaches to 0 from the right, integral of 2 and s dx over x minus 1 squared. So now, before we proceed to apply the case, we need first to integrate the equation. So we need to integrate integral of dx x minus 1 squared. So now, to integrate this, we need to let u is equals to x minus 1. That's good. So du will become dx. So the equation will be du over u squared. So integrate u negative 2 du. This will become u negative 1 over negative 1. This become 1 over negative 1 over u. So this will be the value of our integral. So let's apply the case. So this will become, since we have the value, let's apply the limit where t approaches from the left, negative 1 over u plus the limit where s approaches 0 from the right for u to s. So limit t approaches to 0 from the left, negative 1 over, bring back what's the value of the u. So the value of u is x minus 1. So x minus 1 t0 plus limit where s approaches to 0 from the right, negative 1 over x minus 1 to s. So substitute all the upper and lower boundary to the x. So this will become limit where t approaches to 0 from the left, negative 1 over t minus 1 minus negative 1 over 0 minus 1 plus limit s approaches to 0 from the right, negative 1 2 minus 1 minus negative 1 over s minus 1. So limit t approaches to 0 from the left, this will become negative 1 over t minus 1 minus 1 plus limit where s approaches to 0 from the right, negative 1 over 2 minus 1. I don't know. This will become negative 1 plus 1 over s minus 1. So apply the limit. This will become negative 1 over 0 minus 1 plus negative 1 plus 1 over 0. So it is equals to negative 1 Negative 1 over 0 minus 1 is infinity. Plus negative 1 plus 1 over 0 is equals to infinity. So therefore, the answer is equals to D and E. Therefore, this function is divergent. Let's proceed to number 2 with an integral of with an upper boundary of 1 and the lower boundary of 0, 1 over x dx. So let's first determine what could be the case here. So now, this case is suited for case number 2, which is equals to limit where t approaches to a from the right, integral of b and t f of x dx. Why? Because the f is continuous at b and discontinuous at a. Then this will be our case. So now, limit t approaches to a from the right, t 1 t f of x, no, let's direct it 1 over x dx. So now let's first integrate the integral of 1 over x dx. So integral of 1 over x dx is ln x. So now we have our value of the integral. So now let's proceed to substitute it. So limit where t approaches to 0 from the right. This is 0. I'm sorry. This is 0. 0 from the right. Because our value, the value of our a is 0, right? And the value of our b is 1. So that's why the b changes to 1 here, and the limit will become 0. Okay, nice. So now it will become ln x 1t become limit where t approaches to 0 from the right, ln 1 minus ln t. So apply the limit ln 1 minus ln 0. So the value of ln 1 minus ln 0 will become negative infinity. So therefore, the function is divergent because it doesn't have any value. So now let's proceed to problem number 3. We have here integral of 1 with an upper boundary of 1 and lower boundary of 0, 1 over x raised to 2/3 dx. So what could be our case here? So this case is equals to case number 2 in type 2. Very good. Why? Because this function is also continuous in B at B and discontinuous at A. The same with problem number 2. From the right is equals to B T f of x dx. So it will be equal to limit where t approaches to 0 from the right, 1 t f of x dx. So let's take our, let's change this. Let's apply the equation. 1 over x raised to 2/3 dx. So now let's integrate first the integral. So integral, this will become x raised to negative 2/3 dx. Integrate is equals to x 1/3 over 1/3. So if we change this, this will become 3x raised to 1/3. So we have now our value of the integral. So now let's apply the limit. So limit where t approaches to 0 from the right is equals to 3x raised to 1/3 1t. So is equals to limit where t approaches to 0 from the right, 3 times 1 over 1/3 ay 1/3 raised to 1/3 minus 3, substitute the t raised to 1/3. So this will become, let's apply the limit. So limit, no. If you will apply the limit, do not write the limit anymore because you already apply it. So this will become 3 1/3 minus 3, apply the limit, 0 1/3 is equals to 3 times 1 raised to 1/3 it is equals to 3 minus 3 times 0 raised to 1/3 is equals to 0. So 3 minus 0 is equals to 3. So therefore our function, or the function, is convergent because it exists, because the value of the limit is a finite number. So now let's proceed to problem number 4. We have integral of, with an upper boundary of 1 and the lower boundary of negative 5, 1 over 10 plus 2z dz. So this case is also an case number 2 in the type 2 improper integral. So limit where t approaches to a from the right, integral of b t f of x dx. So now we have here equals to limit where t approaches, what's the value of our a? It's negative 5. From the right, integral of the value of our b is equals to 1. T, copy the equation, 10 plus 2z dz. So now let's integrate 1 over 10 plus 2z dz. So we let u is equals to 10 plus 2z. So our du is equals to 2 dz divided to 2. So du over 2 is equals to dz. So now we have integral of 1 over u times du over 2. Set aside the 2 outside of the integral. So 1/2 1u du. So now the integral of 1u is equals to ln u plus c. So therefore our value of the integral is equals to 1/2 ln 10 plus 2z plus c. So now we have our value. So now let's apply the limit. But when we apply the limit, do not copy the c, because that c represent just as a constant. So now limit where t approaches to -5 from the right, 1/2 ln 10 plus 2z 1 t. So this will become equals to the limit where t approaches -5 from the right, 1/2 ln 10 plus 2, substitute, minus 1/2 ln 10 plus 2, substitute the t, so this will become limit where t approaches to -5 from the right, 1/2 ln 12 minus 1/2 ln, just copy, 10 plus 2 t. So apply the limit. Oh no. Yes, we applied this limit. 1/2 ln 12 minus 1/2 ln 10 plus 2, apply the limit, 0. So now we have 1/2 ln 12. So this value is, or will become, negative infinity. So therefore our answer is negative infinity, or therefore the function is divergent. So now let's proceed to our last problem. Problem number 5 with integral of, with an upper boundary of 1, 0, 3 over x raised to 5 dx. So this case is also one case number 2 in the type 2. Why? Because it is also continuous at b but discontinuous at a. So therefore this case is limit where t approaches to a from the right, integral of b t f of x dx. So now let's copy, equals to limit where t approaches to 0 from the right, integral 1 t 3 x raised to 5 dx. So let's integrate first. So this will become, or rearrange to 3x is negative 5. So this will be 3 negative 5, 3 times minus 4 over negative 4. To be formal, let's have that c plus c. So this is equals to 3 times x raised to negative 4 over negative 4 is 3 over negative 3 over 4x raised to 4 plus c. So now we have our value of the integral. So now let's substitute. So, or apply the limit. So t approaches to 0 from the right, negative 3 for x raised to 4 1t. So substitute the x to the lower and upper boundary. So it is equals to limit where t approaches to 0 from the right, negative 3 4 substitute 1 raised to 4. Sorry, this is too much big. Raised to 4 minus 3 over 4 substitute t raised to 4. So this will become, or let's apply the limit. This will become, so 4 times 1 times raised to 4 is 1, so 4 times 1 is 4, so it will become negative 3/4. So this equation will become positive because negative times negative is equals to positive, so that will become positive 3 over 4 apply the limit 0 raised to 4. So the answer will be negative 3/4 plus 3 over 0. So now this will become an negative 3/4 plus 3 over 0 is infinity. So therefore the function is divergent because the limit does not exist. Thank you for listening, guys. So I hope that you have learned something today about the other improper integral or the improper integral of type 2. Thank you so much for watching and listening, and on to the next topic. Thank you and goodbye.